Good morning, students. Today we are going to discuss about logistic regression. So I want to tell you what is the basic difference between linear regression and logistic regression. So as you have seen this already, we have two types of machine learning algorithm. One is supervised machine learning algorithm and another was in non-supervised or unsupervised machine learning algorithm. So supervised machine learning algorithm we can solve in two ways. One is called classification algorithm, another one is called regression algorithm. So whenever we'll see linear regression or logistic regression, we'll think it comes under the regression, but no. When we are saying linear regression, it comes under the regression problem, and when we are talking about logistic regression, it comes under the classification problem. We'll move further and we'll understand the difference between linear regression and the logistic regression. Now you remember that logistic regression is used to solve the classification problems. Now when we are talking about logistic regression, it is a supervised machine learning algorithm and which is used for classification purpose, and our goal is to predict the probability of that instance to happen or not to happen. We have to predict what is the probability of that event to be happened. Okay, so whenever we are talking about a linear regression problem, we are using linear regression problem for continuous data. So suppose I'm saying if I want to know the age of a person, which will change continuously. If I want to know the price of a house, which will also change continuously. So this falls under linear regression. But if I want to know a person will get hike or not, so I'm dividing the data into two categories: person will getting hike or not getting hike. So this is a discrete problem. So whenever we are having a discrete problem, we'll use logistic regression. So this is the basic difference between linear regression and the logistic regression. Linear regression is used to solve the continuous problem, or we can say the output will be a continuous value. And in the case of logistic regression, the output will be a discrete value. The output will belong to a particular class. So this is the difference between linear and logistic regression. These are the some terminology which we are going to use in logistic regression, and earlier we have used some of the terminology in the linear regression also. So as we move further, these terminologies will be clear to you. So just we'll take a simple example here that how logistic regression works. So I want to know that what is if I'll go. We all know that we have to go for a service of our vehicle. So very frequently we'll go for a service, and I want to predict that if I'll not go for a service, then my car will break down or not. So you can see here we have collected the data from the past, and this is the through the user experiences we have collected the data, and we have drawn here graph as per the user experience. We want to know that the car will break down or not. So you can see here at the x-axis we have written the year of services, and in the y-axis we have written the probability of the breakdown. The probability is lies between 0 to 1 always, as we know, and this is the year of services. So as you can see in this graph, as the year of services are increasing, there is a high probability that car will break down. So you can see through this graph, after 3.5 years, there is a high probability that car will break down. So with this, we are trying to understand, with this data, I'm trying to understand that what is the probability that car will break down or not through the year of services. Okay. So now, when we are saying why we are saying it's a classification problem, so I hope you understood why we are saying it's a classification, because we are trying to classify my data into two categories, that my car will break down or not. So it is a discrete value. We are dividing my data into two categories. Yes, my car will break down or car will not break down. So we are dividing the data into two categories. So definitely it is a classification problem, and to solve the classification problem, and especially if it is a binary classification problem, logistic regression will perform well in such cases. So you can see here, now whenever we are talking about a logistic regression, we'll always use the threshold value, because my probability is lies between 0 to 1 always, and I want to set a threshold value that if my probability is greater than the threshold value, so definitely there is a high probability that car will break down, and if the value of probability is less than the threshold value, there is a less probability that car will break down. So we have set, in this example, we set the probability value or a threshold value which is 0.50. So as you can see in this graph, if there is a probability which is 0.29. So there is a less probability that car will break down. So car will not break down if probability is less than 0.50. But if the probability is greater than 0.50, and in this example, we have taken 0.90. So there is high probability that car will break down. So as the number of years are increasing, there is a high chances that your car will break down without service. Okay. So with the help of, I'm trying to find that car will break down or not through logistic regression. We'll take another examples for better understanding between the difference between the linear regression and the logistic regression, because people will always confuse between linear regression and the logistic regression. So we'll take an example here. So just see here what we are trying to do with this linear regression model. I have an employee rating, and with the help of employee rating, I want to know what is the salary hike of a particular person. So as the employee rating is increasing, your salary hike is also increasing. So salary hike depends on the rating of the employee. So salary hike is a continuous value. It is not a discrete value. So if we have such type of problems, we are using here linear regression. Now, if I want to change the problem here, through the employee rating, I want to know that person will get the promotion or not. I have again employee rating as an input variable or an input variable, and through this input variable I want to predict my output variable, which is I want to know that person will get the promotion or not. So either he'll get the promotion or he'll not get the promotion. So definitely it fall into one of the category. So that is nothing but your discrete data. So whenever we have a discrete data, I'll apply logistic regression. But in the case of salary hike, as salary hike was continuous value, we used here linear regression. So I hope it is clear the difference between linear regression and the logistic regression. Now you see here, if for same problem, if I'm applying linear regression, what will happen? To know the promotion of a person, a person will get the promotion or not. If I'm applying linear regression, then what is happening? I'll draw a straight line, because we know in linear regression, we'll draw a straight line and we will divide the data into two parts. So if I'm saying the probability is what? Either person will get the promotion or person will not get the promotion. So as the employee rating is increasing, there is a high probability that person will get the promotion. So you can see here the graph cannot, we can say that the graph cannot fall here, like it should not cross the 0 or 1, but in this case the graph is crossing 0 or 1, because we can say that the probability is between 0 to 1. Then how your graph can cross 0 or 1 line? So this graph is not a proper graph. So if I'll tilt this graph a little, so you can see the graph is far better than the previous graph. So we can say it's giving a more better visualization here compared to this graph. Now the probability is exactly between 0 to 1, and as the employee rating is increasing, your high chances that person will get the promotion. But still we cannot divide the data into two proper categories. So to get the better visualization or to get the better result, always straight line will not work. We have to use some other method, which we'll discuss further. So here the straight line is not giving me the proper result. So I have to apply some other technique to get the proper result. So you can see here, if you'll see this graph and this graph, you can see we have a better visualization in this graph, because we have not used the straight line concept of linear regression. We use the concept of sigmoid. So if I'm using the sigmoid function, in such type of problem, the solution will be better. You can see here, it's a gradual progress, that as an employee rating is increasing, there is a high probability that person will get the promotion. So the result is gradually increasing or decreasing. So this graph is giving me a better visualization compared to this graph. Then how I found this graph? To find this graph, we are using the concept of sigmoid function, which we'll discuss in further. So whenever I'm trying to apply the logistic regression, we have to find the odd value of the success. In the case of linear regression, I'm just depending on the probability value. But in the case of logistic regression, we have to find the odd value. So what is odd of success? Odd of success is nothing but the probability of event happening or the probability of event not happening, we have to find out. So odd is nothing but theta equal to p divided by 1 minus p. P is nothing but the probability of event happening, which divided by probability of event not happening. So odd value will range always between 0 to infinity. Why we are saying it will range between 0 to infinity? If your probability is 0, then your odd value will be always 0, because 0 divided by something will be always 0. But if your probability is 1. 1 divided by 1 minus 1, it will become 0. So your odd value will become infinity. So odd value range between 0 to infinity, but your probability value will always range between 0 to 1, which we know earlier. Okay, so in that way, you are trying to find the odd values. Now, as I told that in logistic regression, we are using the concept of linear regression, and further we are applying the sigmoid function. So how linear regression will play a role into this? You can see here, as we discuss in linear regression, we are using the linear equation straight line formula, which is y equal to mx plus c, which we are representing here y equal to beta 0 plus beta 1 of x. So if I'll draw a straight line, so this is called my x-axis, this is called my y-axis, and beta 0 is nothing but your y-intercept, and beta 1 is representing the slope here. So we know this, okay? So this is my equation of a straight line. Now, if this straight line equation, if I'll use for predicting the odd value of a success, the odd value of success value we know that, which is p of x divided by 1 minus p of x. And if I'll keep this value at the place of y, and if I'll find the log of that, the equation will look like this. And if I'll try to solve this equation, I'm using the exponential at both the sides. And when I'll solve this equation, I'll get the result of probability. I'm trying to find the result of probability, that what is the probability of event happening or event not happening. So I use the exponential of both the side, and when I'll solve this whole equation, I'll get the final result, which is p of x equal to e beta 0 plus beta 1 of x. And as we all know, beta 0 plus beta 1 of x is nothing but what? Y. So it is nothing but e to the power y divided by 1 plus e to the power y. So this is my equation of sigmoid function also. So why we are getting a curve kind of graph rather than getting a straight line, because here we are using a sigmoid function to find the probability of a particular event to be happen or not to happen. So I hope it is clear that how logistic regression works here. Fine. So through sigmoid, we are getting a curve kind of graph, and you can see that gradually it's increasing. So if your rating is greater than 3 or it is approximately 3.5, so there is a high chances that person is getting the promotion. If your rating is less than 3.5, then you will not get the promotion. So either you will get the promotion or you will not get the promotion, and which we are solving through the sigmoid function. Right? So this is the case of logistic regression. Now, if I want to know the basic difference between linear regression and logistic regression, so as we know that linear regression is used to solve the regression problem, and logistic regressions are used to solve the classification problem. Here, our response variable will be in continuous in nature, but here our response variable will be discrete or categorical in nature. As we discussed that age will increase, salary will increase with the time. But if I want to categorize the person, that person will get the promotion or not, car will break down or not. So that is nothing but categorical kind of data. So it will fall into logistic regression. So other differences, it helps to estimate the dependent variable when there is a change in the independent variable. But in the case of logistic regression, it helps to calculate the possibility of a particular event to happen or not to happen. Okay, for that only we use the odd success concept. In the case of linear regression, we'll have a straight line, but in the case of logistic regression, we'll have a curve, which is we are drawing through the sigmoid function. So this is the basic difference between linear regression and logistic regression. Clear? So what are the applications where we are using the logistic regression? So when we are talking about, I want to predict that I want to determine the weather, what is the weather today? It will be hot or it will be a cool weather. Okay, it will be sunny or it will be a rainy. So I'm categorizing weather into different categories: sunny, rainy, or hot. So this is nothing but a classification problem, and we can go with the logistic regression in that case. So other example is, I have some data and I want to categorize the data into different categories like human or animal or a vehicle. So again, I'm categorizing the image into different categories. So again, it is a logistic regression problem. Now I want to know through the healthcare, I want to determine the person's survival as per their age, as per their revised trauma score, injury severity score, and age. I want to know the person will survive or not. So I want to know I have some data. Through that data, I want to know that person will survive or not. So again, we are categorizing the data into two categories. Either it will survive or not survive. So again, it is a classification problem. Their logistic regression can work. So this is all about logistic regression. Thank you.